Hello there everyone, this is KP the Math G here, and I thought I would revisit this idea of a volume that's revolving about revolving a solid about a line, okay, or an area, if you will. And that line could be the x-axis, or it could be the y-axis, or it could be some other line, x equals 3 or 4, or y equals -1, -2, or +8. That's what we're talking about here. Alright, it is sometimes we have what you call a solid of revolution, and sometimes we have the washer. Well, it's always a solid of revolution, but sometimes when we swirl this out, that we get a solid throughout. All right, there are no holes, there's no circle like a washer method that we talked about before. Okay, but I intend to do both. But now this time in this video, instead of trying to do two problems and showing both methods, I'm just going to do one problem at a time. And I think that's why I want to revisit this, is because I want you to understand it better. Okay, I think one at a time is better. And sometimes when you try to show two different ways, that yeah, okay, it's a good video, but do you understand? Okay, and to me it's not as good of a video if you don't understand. So I'm going to revisit this again, and I trust that you will, I hope that you will bear with me as we go through this again. Okay, well, what we're going to do here is revolve the area bounded by x equals 2 right here, okay, y equals 1, it's bounded by that, okay, and y is equal to 2x plus 1, which is this slanted equation here, this linear equation. Alright, we're going to revolve it about y equals 1. So really, when you think about it, we're going to revolve this thing about this line right here. Okay, I wish I had enough board to show, but if you think about it, it'll put an image like this. It's going to revolve a solid here. Just kind of keep going down like that until it finally. So I'm just trying to get the image for you. It's going to revolve a solid, not a hole, is it? Okay, because if you think about this thing revolving here, all right, it's going to revolve. It's going to make a circular motion way down here. Okay. Alright, and it's going to be solid throughout. Alright. If you had this to revolve around the x-axis, which is my next lesson, you see there is a gap between this blue line and the x-axis. But when we join the dotted orange line with the blue line, you see there is no gap anywhere in this graph. Okay, so we are not using what we call the washer method. A washer method leaves a hole. If you understand the nature of a washer, here's your hole right here. Alright, here's your solid piece right here. But the idea here is it's solid throughout, so you're not going to generate a hole when you revolve that. Okay. Alright, so just kind of keep that in mind, what we're doing here. Alright, so let's revolve this. I'm going to take a partition. I hope you can see that. If not, I'll get a different color. Okay. That's that right there. That's what I want to revolve. Alright, now I'm going to get a different color and extend that all the way down to the x-axis. Okay, all the way down to the x-axis. Always try to go to the axis which you're perpendicular to. Okay, if we're running it this way, make it perpendicular to the y-axis as well. Now I want to know how tall this is, because that's what I'm revolving. You want to know how high this portion is. We don't want the entire hat, the entire thing. We're not revolving it around the x-axis. We're just revolving it about here. We just want this orange section to be revolved. So we want this area right here, just this right here, to be revolved. We don't want anything below this, okay? Just this portion here. Alright, so let's see. This distance from here to here, anytime you touch the y, this right here, all this is y is equal to. This is y is equal to 2x plus 1. Okay, this is y right here, this height from the x-axis. You always start from the x-axis. Alright, so from the x-axis to here, this height is y. Okay, but what is y? Y is 2x plus 1. Okay, so right there, this whole height is y. But that's too much, because we got to subtract off how high this is. Now surely we know how high that is, because we said y equals 1, so that's 1 unit high. So this height here is 1. Okay, so we would like to subtract off that height. So let's say if this height were 10 and this height were 1, this right here would be 10 minus 1, which is 9. Okay, so since this height is y from the x-axis, that's how you measure anything to the graph itself. That height is y, and then so this this height right here has to be y minus 1. So this height is y minus 1. Okay, and that's the part that we want to revolve around this line, y equals 1. Okay, alright, it's going to be a solid throughout. Okay, no holes. Okay, this is my radius right here, so I'm going to put that down, y minus 1, and I need to know how far I'm going from where to where. Okay, sometimes I had trouble with that when I first started learning calculus, but notice here that this isointerval that I just created can move from where to where? From 0, that's right, from 0 to 2. Okay, so we know that we're going from 0 to 2, and this is delta x here. Alright, this thickness is delta x, because it is on the, that's the thickness of x. Alright, so we know that this is delta x, which is dx here. Alright, but we don't want it to be in terms of y. We want to know what y is. Well, y is 2x plus 1. So we always got to remember that. I do this to show what this should look like. Okay, oh, by the way, I have to square this. Alright, so let's see here. Let's substitute this back in. 0, pi, 2, and now y. Y minus 1. Okay, and we're going to take that and square it in dx right here. So y is 2x plus 1. Alright, well really what we have here, if I remove this parentheses, what do I have? 2x plus 1 minus 1. Alright, so I've got 1 minus 1 right here, which really now is what? Yeah, 2x. Alright, so I'll tell you what I'm going to do here is, this is why I didn't want to do two problems. I can flip the board over now, And I know that this is going to be, I'm going to put it over here so we can see it now, and I'll flip it over in just a minute. Pi 0 to 2. What's this left now? 2x. Now don't forget to square that. Now dx. It's pi r squared and then the thickness. Okay? And that's going to give me my volume. Okay? This is an area that's squared times its thickness. That's together the volume. Alright, I'm going to flip this over. Okay? I think I can memorize that a little bit. Yeah. Alright. So what we had was pi. And we were going from 0 to 2. And this was 2x squared dx. Alright, there it is. That's what you have now. And if you can set that up like that, you'll realize what we, you can start to get a picture of how to go about doing this. You get where you can do this consistently, whether you're rotating it on that same line, or maybe a line or two below it, or maybe a line or two above the graph, or even over here to the right or over here to the left. You get where you can do that, you understand it. Okay, that's true, isn't it? Let's square this. Okay, so alright, so 2 squared is 4, and then this is x squared dx. If I want to, I can put the 4 on the outside of the pi. Just remember you got to bring it back in when you solve. Now I just have x squared dx, okay? There is a rule that if I have a to the x squared dx, then I can put the a, and I'm going from, say, c to d, alright? Then I can put the a out in front. A is a constant, or coefficient rather in this case, and then x squared dx. Okay, I can put that. I have a right to do that, just like I have a right to put that pi out there and not use it till I have to. Okay. Alright, I didn't have to do that, but that's just one of the rules. It just makes it easier. Okay, here we go. Let's integrate. So we're going to have 4 pi. Alright, we are going from 0 to 2, and the answer is going to go in here. X cubed over 3. Alright, so really, after we squared this, okay, now it's x cubed over 3. So now we have, just plug the 2 in, so 4 pi. Alright, so 2 cubed over 3. Okay, like that. And also, if I think about it, I always forget that there is a 0. I could put minus 0 cubed to do it, okay, to make it kosher there. That's the right way to do that. That's applying one of the 2 fundamental theorems of the calculus right here. But this is 0, isn't it? That's why I just went ahead and boxed that in. Okay, so anyway, 4 pi. 2 cubed is 8. 8 over 3. This is actually over 1 here. So now I can just multiply this here. 4 times 8 is 32. 32 pi. And if you want to do it like this, you can. Okay, like that. 32 pi over 3. Okay. Just to kind of give you an idea, I'm gonna make a smaller graph here. Okay, I'll just use the same marker. The graph was like this. Okay, it's something like this, wasn't it? On the other side, this was y is equal to 1 here, and what we did was we revolved it. Okay, I want to come straight down like that, about the same length here, and then come across like this. And this is what this swept out when I do a circle. get a different color to kind of show that. Alright, this thing swept around, so the circular, that's the area of a circle is pi r squared. That's when we do that. Alright, remember we're summing up all those little thicknesses, so there's your dx right there. Okay, you're making that circle and you're sweeping this out right here. Alright. Alright, so you can kind of imagine what that looks like, or what that would look like if it were swept, if it went around in a circle. If you revolved that and generated that around and around and around and around. And of course right there, this is what we figured out. This part right here was revolved, but remember we had this also. So this was y, and this is 1, so this part was y minus 1, okay? So when we had the 2x plus 1, and then we had the minus 1, and we're squaring all of that, that just put us down to 2x squared right there, didn't it? Because these canceled out or subtracted off, okay? And that's how you do it. You just kind of have to think about what we're doing. Okay, so that's the video that I want to show. I feel like when I try to show more than one of these examples, this kind of stuff can get confusing very fast. And I'm just kind of relating from my own personal experience. When I first started learning this, it's not easy, okay? And I had to study this all over again. Once I did learn it, I had to kind of, I'm not saying relearn, but I had to just kind of go back over it again and review it, and you know, you just make sure that you were right. I had a professor to say to me a long time ago, convince yourself that you are correct. And that's what you are in the business of doing. You convince yourself, but you must do it in the right way, okay? And that's what I'm here for, is to show you the right way to convince yourself, okay? And you'll get where you can convince yourself, just like I've had to learn it myself. So anyway, alright, anyway, we have been gone all from last Wednesday till Sunday. Today is Tuesday. I wanted to play this video all day Monday, but we were just swamped with business-like things we had to take care of. And so my wife and I just spent a little time doing business stuff. We had a really good time. We went out of town, and it was my wife's birthday, and I really, you know, we had a really good time together, and I appreciate her so much. Alright, well anyway, this is KP the Math G signing off. You guys have a great, great day.